Hi guys, and welcome to Module 12. In this module, we are going to talk about naming points in the coordinate plane, and we start with the 4 different sections on the coordinate plane. Remember, on the top right-hand side, you have quadrant 1, and then you count your quadrants counterclockwise. So quadrant 2, 3, 4. Next, we talked about independent and dependent quantities from a table. We talked about the dependent variable being the one that depends on the other, and the independent variable being the one that the quantity depends on. In this situation, we have a train moving at a constant speed. The distance y in miles that the train has traveled after X hours is shown in the table. So the two quantities in this situation are your time in hours and your distance in miles. The quantity that depends on the other is the distance, because the distance depends on the time. So the independent variable here would be time, and the dependent variable, because it depends on the time, is your distance. When talking about describing relationships between independent and dependent variables in a graph, the independent variable is usually shown on the x-axis, and the dependent variable is normally on the y-axis. So when graphing this relationship between these two variables, we have this situation where we have a carton of eggs, and as x increases by 1, y increases by 12. So this is showing 1 carton equivalent to 12 eggs. So the relationship is multiplicative. The value of y is always 12 times the value of x. So the graph could represent the number of eggs in cartons that each hold 12 eggs. The independent variable, which is your x-axis, is the number of cartons, and the dependent variable y is the total number of eggs, because the total number of eggs depends on your number of cartons. When writing an equation to represent a real-world relationship, we have this real-world situation where for every dog, Amanda earns $8. So we look at this table, we have the dogs walked, 1, the earnings would be $8. If Amanda walked 2 dogs, then she would earn $16. 3 dogs, Amanda would earn 24. So what's happening is this is a multiplicative relationship where we are multiplying by 8. So if Amanda walked 5 dogs, then she would make $40. If Amanda walked 10 dogs, she would make $80. And if she walked 20 dogs, she would make $160. This is another example of writing an equation that expresses y, your output, in terms of x, your input. So for every x, your y is 0.5. If you have 2 as your x, then when you multiply that by 0.5, you get 1. So the relationship here is y equals 5/10 times x, or half of x. The input-output relationship doesn't always have to be multiplicative. In this case, the relationship between x, the input, and y, the output, is y equals x plus 3. And you can see this is a rule for every x. So 2 plus 3 equals 5, 4 plus 3 equals 7, 6 plus 3 equals 9, and so forth. In this example, a student modeled the relationship in the table with the equation x equals 4 times y. The student made an error because the equation should be the complete opposite. The equation should read y, or output, equals 4 times x. because what's happening is in order to get your y or your output, you are multiplying x times 4. In this slide, we reviewed the distributive property and we were asked to match the equivalent expressions. Now remember, with distributive property, you're going to take every number on the outside and multiply it by every number on the inside of the parentheses. So for example, when we look at this first one, we have 3 times 2x. That's going to be 6x. 3 times 3 is plus 9, and then we have a minus 5. Well, we can take these like terms, 9 and 5, and 9 minus 5 is going to be equal to 4. So we're left with 6x plus 4, and that one matches here. Let's go ahead and erase this, and let's do the next one. Okay, the next one is half of 4x, which would be 2x. Half of negative 4 is negative 2. And then we're left with that plus 3x. Again, we could take these like terms, 3x and 2x, and combine them. That means 5x minus 2. And so this equation is equal to this one. Let's go ahead and erase this and do the next one. All right, the next one is a quarter times 4x, which really means x. A quarter times 4 really means 1 minus x. Well, we can take this plus x and combine it with minus x. They cancel each other out, a plus and a minus, and we're left with just 1. So this equation equals this one. And let's just erase this last one. And let's check this last distributive property to make sure that we're left with the right answer. So 6 times x is 6x. 6 times 2 is plus 12 minus 10. We take these like terms. Plus 12 minus 10 is plus 2. And we're left with 6x plus 2. And yes, that is the last one left. In this slide, we're going to represent algebraic relationships. We have a young lady, Angie, who's walking at a speed of 5 kilometers per hour, and May is walking 4 kilometers per hour. So we have two different tables to show how the distance that each girl walks is related to time. So we're going to take let's take Angie first. And we have for every hour she's walking 5 kilometers. So what we're doing is a multiplicative relationship where we are taking x or your hours and multiplying by 5. So 2 times 5 is 10, 3 times 5 is 15, and 4 times 5 is 20. Let's go ahead and work with May's table next. The multiplicative relationship here is she's walking 4 kilometers per every hour. So what we're really doing is multiplying 4 times x or your hours. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and 4 times 4 is 16. So now we can graph this algebraic relationship. So going back to Angie's equation, she was y equals 5 times x. So going back to the table, the distance was dependent on the time. So we start the table at 0, 0. And then we go, according to the table, 1, 5. Which would be somewhere here. We have 2, 10. 3, 15. Which would be somewhere here. 4, 20. And we have 5, 25, which would be somewhere up here. And so we're going to plot the points from the table and then connect them with a line. And we can see an upward trend there. We're going to do the same thing with May's equation. May's equation was y equals, remember she was going 4 miles per hour, so 4 times x. And so again, we start at 0, 0, and then we go 1, 4, 2, 8, 3, 12, 4, 16, and 5, 20. And again, after we plot the points, we're going to connect them with a line, again showing an upward trend. Here we're going to write an equation from a graph. We have this young lady who pays an entrance fee to visit a museum, and then she buys souvenirs at the gift shop. Based on this relationship, we see that if she doesn't spend anything at the gift shop, she's still paying $5 entrance fee. So the total amount is definitely dependent on the gift shop amount. If she spends $5 at the gift shop, she's going to spend a total of 10. So the multiplicative relationship here is she's going to spend plus 5. So if she spends $10 at the gift shop, she's going to spend a total of $15. If she spends $15 at the gift shop, she's going to spend a total of $20. If she spends $20 at the gift shop, she's going to spend a total amount of $25. When graphing an equation, we have the ordered pair xy. Remember, x comes before y in the alphabet, so x always comes first. That makes an equation like y equals x plus 1 true. This is called a solution. And in the next slide, we're going to see all the ordered pairs that are solutions, and we're going to graph them. When you have an equation like y equals x plus 1, your first step is to make a table of values. Remember, we talked about what your table is going to look like. It's going to include your x, your equation, x plus 1 equals y, and then that will give you your ordered pair xy. So step 2 is to plot the ordered pairs from the table. And I told you guys always start with 0. In this case, the book started with 1, and that's okay. So what you do is you plug in your x values. So 1 plus 1 equals 2, which means that your x is 1 and your y is 2. Next, if your x is 2, you plug that in. 2 plus 1 equals 3, so your x is 2 and your y is 3. Your x is 3, so you plug that in. 3 plus 1 equals 4, and so your ordered pair would be 3, 4. And once you have your x and y ordered pair, that is what you graph. So for example, 1, 2 would be right here, 2, 3 would be right here, 3, 4 would be here, and so forth. This concludes our review of Module 12. If you have any questions, please feel free to ask.